Okay, so let's look into this. Linear relationships can be proportional or non-proportional. A proportional relationship means that there is a constant ratio between the values of x and y. Complete the table below. Review the difference in proportional and non-proportional relationships. Okay, we've looked at both. So here is the thing. Proportional relationships can be written as y equals, and sometimes they use, instead of m, they use k. So I'll use k, x. So that's the linear equation for a proportional relationship, where k is the slope or rate of change. Let me highlight that. And so if I gave you an example, it would be maybe y equals 1/2 x. That's an example of something that's proportional. Okay. The ratio, so I'm continuing here. The ratio of y over x is constant. So that tells us that if I divide y over x for any of these, 6 over 2, 12 over 4, 18 over 6, 24 over 8, they're all the same, aren't they? 3 over 1. Okay. Any graph that is both linear and constant linear and contains the origin. Yes, Gabriel.
I was going to ask if doesn't it have to pass by the origin?
Yes. It has to go through the origin. That's the main difference when we're looking at the graphs. When it's proportional, it goes through the origin. So one of the coordinates we could have put here is 0, 0. All right, so that's proportional. So non-proportional can be written as y equals mx plus b. Where m is the slope and b does not equal 0. So let's go ahead and highlight or underline that. So make up your own equation for example. I'll make up my own. Y equals 2/3 x minus 4. My slope is 2 over 3. My y-intercept b value is -4. And here's the difference. The ratio y over x is not constant. So let's just take a look. If we do 8 over 2, 14 over 4, 20 over 6, 26 over 8. If we simplify all of them, they all equal different values, don't they? Yeah, this one's 4 over 1. This one would be what, 7 over 2? This one would be 10 over 3. Yeah, they're all different. So any graph that is linear, that is not linear, or that is not linear, or does not contain the origin. Okay, and as you can see, this crosses the y-axis somewhere other than 0, 0. Okay, so today mainly we're going to be comparing one to the other. So we're going to complete each representation for the situation described below, and then we're going to determine if the situation is proportional based on each representation. Okay. Alexis, would you read number 1 where it says Hillary, that paragraph?
Hillary's looking for a gym to join. A local gym, Forever Fit, is offering a special deal where new members pay $30 per month with no sign-up fee.
Okay. So $30 a month and no sign-up fee. So what could our equation be? $30 for every month, and x. Okay, so besides that, let's determine what is y and what is x. Let's make sure we know what our variables represent. If we're using the equation y equals 30x, what's y represent?
The cost. Total cost.
Total cost. And how about x?
Number of months.
Number of months. Okay, so let's use that to fill out our table. How much would we pay right at the beginning at 0? Well, let's use it. 30 times 0 is 0. Yeah, that's where the no sign-up fee comes in. They don't charge you a sign-up fee, so you don't have to pay something up front. How about after month 1? 2? And the third month? That's a good deal. All right. Well, let's go ahead and plot some points. Let's use this x and y to plot these points. We're going to do, this would be at the beginning. After 1 month, we paid 30, so that would be right there. After 2 months, we paid 60. The third month, we paid 90. What would we pay at the fourth month? 120. Okay. And if we add 30 to that, what would we pay? 150. And then we add 30 to that, we would pay 180. And then after that, we ran out of graph, right? Okay. So here's where we put together what we know about proportional and non-proportional from equations, tables, and graphs. Let's go to the equation. Well, first of all, is this proportional or not? Yeah. Definitely proportional. How can we tell on a graph? Can someone raise their hand and tell us, how do we know by looking at the graph? Jasmine. Well, that might be helpful in the graph. I'm sorry, you said the graph, right? You're right. Let me jump to that. You're right. So it passes through the origin. That's what we want to look at on the graph. Um, how about on the equation? Yes.
There's no plus anything. It's just that number itself.
Yeah. So there's no constant added. So I'm going to say this: models the equation y equals kx. There's no plus anything, like Gabriel said. So we use this model for that equation. Okay? So we have passes through the origin for the graph, models the equation y equals kx, so it doesn't have plus or minus anything. Okay? Yeah, Kaylee.
For the table, you can see that the ratio of y over x is constant.
Ratio of y over x is constant. Very good. Yeah. Besides 0, 0, we ignore 0, 0. 30 over 1, 60 over 2, 90 over 3. All reduced down to 30 over 1 or 30. So perfect. Okay. Great job, guys. Okay. Anyone still writing any of this down? Yes. Because now we're going to try a different one. So Jasmine, would you mind reading number 2? On the back.
His name?
Javier.
Javier is ordering custom glasses for an upcoming event. The website he is ordering from will charge $2.50 per pair of sunglasses and $5 for shipping. Boy?
Yep.
I'm not paying for shipping.
Unless you have Amazon Prime, you may have to. All right. So which one shall we do first? The equation, the table, the graph?
Actually, not a table.
Okay. Let's try the table. So based on what we know here, how much will Javier pay for 0 pairs?
$7.
Well, just the shipping and handling would be $5. So he has to pay that no matter what. So even at 0 glasses, that has to be paid. At 1 pair of glasses, that would be
$7.50.
how about
13.
uh,
14. 15, sorry.
well, hold on, 2 pairs of glasses.
Oh, it's 10 because he already paid for shipping.
Yeah, you got to pay the $5. And then how much will 2 pairs of glasses, just the glasses? $5. 250 is 5, so $10. Okay, how about 3 pairs?
12.50. 12.50.
I mean 12.
$12.50. All right. So maybe that'll help us come up with the equation. Let's use, looks like cost is y, x is the number of glasses. Gabriel.
The equation is y equals 2.5x plus 5.
Okay. Yeah. $2.50 for every pair times x is the number of pairs plus the $5 for shipping. All right, let's graph it. So we're going to start at 0 is at 5. 1 pair is $7.50. So let's say it's maybe right there. 2 pairs Maybe I moved it up too high.
Yeah.
I put it up too high. Oh well. Let me bring it down a little lower. There we go. Ignore that upper point. That's better. 3 pairs would be 1250. 4 pairs would be 15. Okay. I think we got the idea. Do one more. There we go. Okay. So proportional or non-proportional? So when it has proportional, we're going to say no. Okay. So which equation does this model?
Y equals mx plus b.
Models the equation y equals mx plus b. Okay. How about the graph? Let's jump to the graph. What in the graph, Ivan? Yeah. The main thing is it doesn't contain the origin. Let's just go with that one. How about the table? Kaylee.
The ratio y over x is not constant.
Yeah. Basically the opposite of when it is. So if we do the ratio of y over x, ignoring 0 always, it's not constant. Okay. So for the next, I'm going to let you try this a little bit on your own. You can check with your table partners, but label the representation, and we've got a few of them here, 3 through 8, as proportional or non-proportional. Justify your choice. So give a reason why. So you're going to look at equations, tables, and graphs, and you're going to decide proportional or non-proportional and explain why. Okay, I'll give you some time to work on that. All right, so let's start with number 3. Let's proportional, non-proportional. Everybody, proportional. My reason would be it follows y equals kx. Okay. Um, how about number 4? Proportional or non-proportional? It is proportional. Y over x, for all of these, I know they seem a little weird, but they all follow the same. Y over x, they all simplify to what? Yes.
Couldn't you just multiply them? What it goes by -6. Like it goes by 1.5. Couldn't you have just multiplied it by -3?
Yeah. Absolutely. Yeah. And what was the ratio too?
1.5 over 1.
Yeah. You could do it that way over 1, or you could just do 9 over -6, which is, what is it? 3 over 2. -3 over 2. Or -1.5 over 1. How about proportional or non-proportional? Number 5 is non. Does not go through the origin. How about number 6? Denzel has $13.50 and saves an additional $7.50 each week. Proportional or non-proportional? Yeah, I could write the equation y equals, bless you. I could write this equation to model that, right? So I could say models. What does it model? Y equals mx plus b. And what did we decide here? Non-proportional. Because it's nonlinear. Number 8, look at the ratios. 18 over 8, 20 over 10, 22 over 12. Are they the same each time or different? Different. Y over x is not constant. All right. Let's get started on the work. I think we're good. I want to give you guys some working time. So we'll end it here.